So for today's, we're going to be looking at 4 very quick topics. The first topic we are looking at is parametric representation of lines. All right, this is parametric representation of lines. So let's say we have 2 vectors. We have vector A equals to 2 and 1. Then we have vector B equals to 0 and 3. Now the question in this topic is that, show me the parametric line that goes through these 2 vectors, right? I want to see the parametric line, because this is the way we can understand what's happening in machine learning. I mean, it's as basic as possible, but then it gives you an intuition into what's happening between when we start vectors and matrices, right? So let me do some labeling. So this is 1, this is 2, this is 3, this is 4 on the y-axis, this is 1, this is 2, this is 3. So vector A21, that's our A on the x-axis, 2, 1. So 2, 1 will be somewhere here. So let me draw my vector A. 2, 1 will be somewhere here. Right? Vector B is 3, 0. So 0 on the x-axis and then 3 on the y-axis. So let me draw my vector A and vector B this way. Of course, you know I can't draw it on this line. It's supposed to be on this line, right? So this is vector B. This is vector B. Right? So the parametric equation or the parametric line for these 2 vectors is the line that goes through the end of these 2 points, right? So I'm going to show you this way. So any line that goes through these 2 points till infinity any line that goes through these 2 points till infinity is vector. We can call it vector C, but mathematically, this line is going to be vector B minus vector A. Vector B minus vector A. And then we can go ahead to derive the parametric equation for this line, but I don't think it's very important for machine learning. But all you need to do to derive that is to add just any scalar. Add any scalar. The scalar could be, vector 1, 1, of just add any scalar or any vector to this vector B minus A. You'll be able to get the parametric equation for this line. But that will not be very important for this discussion, right? So the next topic, which is the first very important topic that we are going to treat for mathematics and machine learning, is linear combination. So let me open a new tab. So linear combination, right? So it's actually linear combination and spans, but we'll first treat linear combination. When you understand linear combination, then you can understand what a span is, right? So let's say we have 2 vectors. Once again, vector A is 1, 2, and then vector B is equals to 0, 3. vector A is 1, 2. I need to write this down as I'm writing it, right? Now, what is a linear combination of A and B? Linear combination of A and B, right? Let me write it down for emphasis sake. It's any constant or any number times vector A plus any constant times vector B. So any constant. So for example, we could decide to do 3 times vector A and minus 2 times vector B. This is a linear combination of this vector, right? We can decide to say 7A plus 3B. This is another linear combination of this vector. But the question is that why do we call them a combination, right? We call them a linear combination because we are just basically scaling them up, right? And let me show you what scaling up is. If we have a graph and we have vector 1, 2 would be 1, then 2. Vector 1, 2 would be something like this, right? If we decide to scale up this vector 1, 2 by 3, that's vector A by 3. We are going to have vector 3, 6. Vector 3, 6 would be, let's say this is 3 here, and this is 6 here, right? Vector 3, 6 would be something like this, which is just 3 times vector. If we multiply it by 2, vector 2, 4 will be somewhere here. So you can see that we just basically scaled up vector 1, 2, right? So it's called linear combination because we are just basically scaling them up, right? We are not multiplying the vectors by each other, right? We are just scaling them up. If we multiply the vectors by each other, then they become non-linear, right? So the linearity goes once we multiply them by each other, but now we are adding them. We are multiplying them by constants and adding them up. All right, is that why we call them linear combination? But now the next question I want to ask you is that why is this important? Now, this is important because in machine learning, we are going to do linear regression next week, right? Linear regression is just basically y equals to mx. Your normal y equals to mx plus c. So y is what you are predicting. So for example, you want to predict if a patient is going to be readmitted in the hospital. That's your y. That's your y-axis. And the feature you are using, right, could be their diabetes reading. So let's say this person's reading is 126. What's the reading for this blood sugar again? I've forgotten, right? This is your target variable. This is your feature, right? What you are using to determine is the constant. M is the constant. Because what we are looking for in machine learning is the constant. So a lot of times we say machine learns from data. Machine learns from data. It learns from the feature you give to it, right? But what the machine is actually deriving is the constant. That's why these constants are very important, because they are what we are looking for in machine learning. These constants. The variables themselves or the vectors themselves are not what is very important. But what the machine is learning is this constant, this M, right? So is this blood sugar reading, for example, that will tell you that, okay, this patient is likely to come back. So let's say we have a model. Let's say this is our model we are using to predict, right? And let's say this is 50, this is 100, this is 150, this is 200. And we have this plane of yes and no. So we are saying that if the patient is, so this model is telling us that if this patient has less than 100 for his blood sugar reading, then it's very likely that the patient will be readmitted. And this model is telling us that if the patient has over 100, right, for his blood sugar reading, then it's very likely that the patient is going to be admitted. This is a very simple linear regression model, right? But what we are trying to understand in machine learning is the constant, this M, which is the reason why we are learning linear combination. So let me go back to linear combination. So let me go back to linear combination. So let's look at what 3a minus 2b looks like on our graph, right? I mean, this is just basic stuff. So let's label our graph. So this is 1, 2, 3. This is 1, 2, 3. This is minus 1, minus 2, minus 3. Minus 1, minus 2, minus 3. Right? Vector A usually will be 1, 2. So 1 on the x-axis and 2 on the y-axis. That will look something like this and give us this. So this is vector A. But 3a, multiplying this by 3 now, is going to give us, that's 3 times this vector, right? So it's going to give us something like this. So this is scaling it up by 2, right? Now scaling it up by 3. I don't want to go through the usual process. Scaling it up by 3 will be something like this. So this is 3a. 2b, right? Since b is 0 on the x-axis and 3 on the y-axis, so 2b would look something like this, right? So this is 3a and this is 2b. Excuse me. B, we are multiplying b by 2. So 2b would come something like this. So we're going to have this full length is going to be b. Right? Now, if I take, oh, sorry, I made a mistake. I made a mistake. 2b, this is 0, this is x, and this is y. Okay, sorry, I had 3, 0 in my notes. That's why I was making the mistake. In my notes, it was 3, 0. In my notes, it's vector 3 and 0. So 3, 0 will give us 3 on the x-axis. So vector B would be something like this. Let me draw it very close to the line. 1, 2, 3. Right. That's vector. Now, my question is that what is this line? I mean, it's very obvious to you, right? The line between here and here is going to give you what? Right? The line between here and here, sorry. Line between here and here should be on the same plane anyways. It's going to give you vector 3a minus 2b. I'm going to need you to derive that yourself. Right. So, but what I'm saying is that this is just one linear combination for these two vectors. We can have millions of linear combinations. We can do 5A plus 3B. We can do 6A plus 7B, right? Those are different linear combinations. Now, linear combination now takes us to span. What is a span? So let's open a new now takes us to span. Now, what is a span? Right? Okay, let's define it. Let's define it before we go into the span of the vector A and B is all possible vectors in R2. In R2. R2 is, of course, R2 is two-dimensional real coordinate space, or real coordinate space, right? So for example, let's take an example. No, let me do it this way. Let's say we have a vector A equals to 2, 2, and vector B equals to minus 2, minus 2. So vector A is 2, 2. So let's say this is 1, 2, 1, 2. Vector A will be somewhere here, right? Let's say this is minus 1, minus 1, minus 2, minus 1, minus 2. Vector B will be somewhere here, right? Now, the span of these two vectors is all possible vectors in this region. So the span of this vector is all possible vectors in this region. So let me make it make sense. The span of these two vectors, right, is all possible vectors on this line. That's why we treated parametric equation of lines, right? So the span of this vector is all possible vectors in this line. Another example is that if we don't want to take these two vectors, for example, because we'll be taking two vectors in money. So the question now is that what is the span of vector A, right? To show you the span of vector A on the graph, right? The span of vector A is every possible set of vectors, right, on this line. So another way to define span is that every linear combination is a span, right? So for example, if we decide to do vector 2 times 2, that's vector 4, 4. We'll find it on this line. If we decide to do vector 2 times 3, that's vector 6, 6. You find it on this line. If you decide to do vector 2 times 4, that's vector 8, 8. You find it on this line, right? So this is the span of vector 2, 2. I hope that makes sense. So any combination of A will end up on this line. Any combination of A and B will end up on this line when you go to the minus part of it. And that question is that what is the span of vector 0, 0? So vector 0, 0 is here. So stop to ask yourself a question. What is the span of vector 0, 0? Correct answer is that the span of vector 0, 0 is vector 0. Right? Or another hypothetical question is that what is the span of vector A? Of any hypothetical vector A, right? It is all vectors that you can get by creating a linear combination of just A. Now, this is very important. All vectors that you get by creating a linear combination of just vector A. Right? So to explain span further, let me show you something. So let's say we have a vector A equals to 1, 2. Vector B equals to 0, 3. And then vector X equals to X1, X2. Right? I'm trying to prove to you that I can get any X1, X2, right, by adding some combinations of A and B. I can get any vector X or any vector C, let's call it vector C. I can get any vector C by adding some linear combinations, right, of A and B. That means by adding a constant C1 to A and adding a constant C2 to B, I can get any vector X. Should I prove it to you? I should prove it to you. Okay, no problem. Let me prove it to you. So we are adding constant C1, right, to 1, 2. And then we are adding constant C2 to 0, 3. This will give us X, right? So let's interpolate now. The X-axis will give us 1 C1. Or let me just write just to make it better. So 1 C1 plus 0 C2. 0 C2 will give us X1. Good. 2 C1, this is 2. So 2 C1 plus 3 C2 will give us X2. So what we are saying is that I can find any value of C1. I can find C1 and C2 for any value of X. Meaning is that I can find the weight for any output, right? So let me just arrive at my answer. So now let's multiply both sides by -2. If I multiply both sides by -2, or if I multiply the first equation by -2, multiply this by -2, what I'll get is this. I'll get -2 C1 plus 0 equals to -2 minus 2x x1. And then I have 2 C1 plus 3 C2 equals to x2. So what I'll do is take a subtraction. So if I subtract this from this, right? So if I subtract this from this, what I'll get is this. I'll get zeros because minus 2C1 plus plus 2, sorry, I'm not subtracting, I'm adding. So I eliminate C1, right? So I'm going to get 0 for this plus 3C2, which is going to give me, which is going to be equal to x2 minus 2x1. Does that make sense? So that's x2 minus 2x1, such that C2, if you do your interpolation, C2 is going to be 1 over 3 in bracket x2 minus 2x1. Do your interpolation and let me know. So C2 is going to be this. So I already have a value for my C2, which is my second constant. Now I want to get a value for my first constant. Now remember that from this first equation, this is 0, right? So x1 is equals to C1. So remember that from here, to solve this easily, from here, x1 equals to C1. x1 equals to C1. So if we bring it into this equation, right, C2, so we have C2 equals to 1 over 3 in brackets x2 minus 2x1, then C1 equals to x1. What I've just done to you, what I've just done right now is to prove that if I put any value of C1 and C2, I'm going to get any linear combination of vector A and vector B. I'm going to get any linear combination of vector A and vector B. Should we try? Okay, so let's try. So let's say what linear combination of A and B will get us to vector 2, 2. So vector 2, 2. What linear combination of this vector and this vector will get us here? So let's do it now. C1 is what? C1 equals to x1, right? So we can get our C1 equals to 2. And then C2 equals to 1 over 3 x2 minus 2 x1. I hope this makes sense to you. So we know that C1 equals to 2 already, right? Since x1, this is x1, and this is x2. Now, C2, we want to get C2 now, equals to 1 over 3. X2 is 2, that's 2, minus 2 times 2, minus 4. 2 minus 4, right? So C2 equals to minus 2 over 3, right? So now let's go and verify it ourselves. 2a minus 2 over 3b. What do you want? What do you want? Okay, would give us 2, 2. So let's go. So 2a, which is vector 1, 2, minus 2 over 3 vector 0, 3. What does it give us? It gives us 2 times 2. That's 2, 4 minus 2 times 0 is 0. 3 times 3 is 9. Right? No, this is not correct. Okay. I'm making a mistake. Okay, sorry, I made a mistake here. Two over 3 times 0 is 0, right? Then 2 over 3 times 3 is 2. So this will give us 2 minus 2, 2 minus 0, 2, 4 minus 2, 2. At the end of the day, this gave us 2, 2. Right? So this is the end of linear combination and span. I hope it makes sense. If it doesn't make sense, please just ask your questions in the group, or maybe I'll just take this again on my whiteboard so that you can understand it better.